The top view of AB, small ab, of a straight line, capital AB, is 60 mm long, makes an angle of 30 degree with XY line. The NDA is in VP and 30 mm above HP. The NB is 65 mm in front above HP. Draw the projections of the line capital AB and determine the length of the front view and its true length and its true inclination with reference planes. Now, so here, the top view of the line capital AB of a straight line, the top view of a small AB of a straight line capital AB is 60 mm long, makes an angle of 30 degree with XY line. The NDA is in VP, so since it is in VP, obviously that line will go to, that point will going to be on horizontal plane. And 30 mm above HP. So when you look from the front view, we can see the distance above HP. So it will going to be A dash, which is on vertical plane. And NA is in VP. So when you look from the top view, the image will going to be on the horizontal plane. It is small a. And the top view of the line, small AB, 60 mm long, makes an angle of 30 degree with the XY line. So he says it is a top view. So the image will going to fall on the horizontal plane. With the NDA as center, you take the angle of 30 degree and draw an inclined line. And by using the compass, take 60 mm radius with A as center, cut an arc on that 30 degree line, so that you will going to get the small b. So AB, which is 60 mm long, inclined at 30 degrees to VP, or 30 degree with the XY line. So you can see this will going to be the top view line. You join A and B with a dark line, and then you will going to get the locus of B in the top view. Similarly, the NB is 65 mm above HP. So from the XY line, you measure 65 mm and draw a horizontal dash dot line, which will going to be the locus of B in the front view. Because when you look from the front view, we can see the distance 65 mm above HP. That will be, image will going to fall on the vertical plane. So you will going to get that distance, which is going to be 65 mm above HP. So now we have the locus of B in the front view and also the locus of B in the top view, and we know the top view distance. Since the distance between the end projectors in the front view and top view will going to remain going to be on the same line, and cut the locus. So we have the top view. So you from here you draw a vertical projector to the XY line, and then again you draw a vertical projector in the vertical plane, so that this will going to cuts the locus of B in the front view, which will be B dash. Then join A dash B dash with a dark line. So this will going to be the front view, and this will going to be the top view. Now we need to find out the true inclination with respect to VP and also the true inclination with respect to HP. Now we have projected the point B from here, the vertical projector, and we have drawn from B dash also you have taken the horizontal projector. So when it is intersect with each other, so this point will going to be the capital B, which is the actual line in space. So this is the capital line, capital AB. Now we need to find out the true length in the vertical plane. Since we need to find out the true length in the vertical plane, so we have to make the line parallel to VP. So with A as center, take the radius of AB. Since A is in VP, so you also, when it is rotated, such that the B will also be on VP. So you rotate that point in space so that B will going to touch us the vertical plane. So now capital AB1 is the line which is parallel to VP. So you are going to get the true length in VP. So that will be A dash B1 dash. Then join A dash B1 dash with a little bit thicker than the projector line. So you are going to find the true inclination with respect to HP. So by doing so when it is in space, so actually what happens, and this rotation, when you look from the top view only, we will be able to see. So you take the top view point which AB, which is rotated such that A is in VP, so B1 is also in VP. So AB1 is the line which is parallel to VP. So we are getting the true length in VP. So we are projecting this so that you will going to get A dash B1 dash, which will be the true length in the vertical plane. Now similarly, we need to find out the true length in the horizontal plane. So to do that, with A as center, take the AB as the radius. When you rotate such that A is above HP by 30 mm, so B2 is also above HP by 30 mm. So with A as center, take the radius of AB, rotate such that B is also above HP by 30 mm. So you are going to get this AB2. So when you are looking from the front view, The line A dash and B2 dash is the line which will going to be parallel to HP. So here, since A dash B2 dash is the line which is parallel to HP, so you're going to get the true length in HP. So this will be AB2. So this AB2 is the line which is in space, which is parallel to HP. So it is the true length, since it is parallel to HP. So when you look from the top view, you can get the true length directly. So when it is projected onto the plane, horizontal plane, you get A is in VP and B2 is on the locus of B. So this will going to be the true length and determine the true length of this line and also the inclination made by that with respect to VP, which is phi. And now when you are doing it in space, when you are rotating this point B in space, so what happens? Since you are rotating the front view line such that AB, which is above HP by 65 mm, is rotated such that it will come to 30 mm above HP. So when you are doing that in space, actually when you are looking from the front view, the image which is A dash B dash with A dash as center, take the B dash A dash B dash as the radius. You draw an arc such that A dash B2 dash is above HP by 30 mm. And then when it is projected, so this you are projecting down directly from the space to the horizontal plane. So that is the path traced here is from B to the image will going to be on the XY line. Since we are projecting like this to get this point, so we are projecting here so that it will going to cut the locus of B here, so that you are going to get small AB2 is the true length, because that line, this a capital AB2 is the line which is parallel to HP. So now join AB2 with little bit thicker than the projector line, so which will going to be the true length, and the inclination made by this with respect to VP is phi. So this is how we will be able to analyze this problem in 3D. But now we will going to do the problem in the sketchbook. First we will going to draw the XY line and mark XY and identify the plane which is VP above XY line and HP below XY line. Now the NDA is in vertical plane. Since it is in vertical plane, the image will going to be on the horizontal plane. So you are going to put the take the point on the XY line and mark this point as small a. And 30 mm above HP. So above HP is seen in the vertical plane. So from the XY line you measure 30 mm and draw a horizontal line. From the point A you draw a vertical projector to the front view so that it will going to cut the point on the horizontal line which is A dash. Then with A as center, by using the protractor you measure an angle of 30 degree, because the top view of small AB of a straight line capital AB is 60 mm long. Makes an angle of 30 degree with XY line. So with small a as center, by using the protractor you measure an angle of 30 degree and draw an inclined line. Then since the top view of the line AB is 60 mm long, so with A as center take the radius of 60 by using the compass, cut an arc on this 30 degree line so that you will going to get the locus of B in the top view. And since it is 60 mm 30 degree line which is small AB, so you mark this point as small b, so that is the top view. Then the NB is 65 mm above HP. So from the XY line you measure 65 mm above HP, that is in vertical plane, and draw a dash dot line which will going to be horizontal dash dot line which will be 65 mm above HP. So this will going to be the locus of B in the front view. Since you know the top view and the front view have got a locus, from B you draw a vertical projector to the front view such that it will going to cut the locus of B in the front view. So since it is B, and this point will going to become B dash, then join A dash B dash with a dark line. So this will going to be the front view. So you measure the inclination, you measure the length of this line, that is length of the front view we need to find out. Next, now we need to find the true length and its inclination with reference to the HP and VP. So now we need to, since we have the locus of B in the front view, so now we have the top view, so you make the top view line parallel. So once you make the top view line parallel with A center, take the radius of AB and draw an arc such that AB1 will be parallel to VP, because A is in VP, so B1 is also becomes in front, B1 is also in VP, so that AB1 is the line which is parallel to VP. That you can understand here. With A as center, when you are taking the B as the radius, when you rotate and make that B1 to rest on vertical plane, so that AB1 will be parallel to VP. So when you look from the top view, A is on VP, B1 is also on VP. So since that line is parallel to VP, so we are finding the true length in VP. So you are From here you draw a vertical projector such that it will going to cut the locus of B in the front view, which is B1 dash. Then join A dash B1 dash with little bit thicker than the projector line and measure the inclination with respect to HP, which will going to be theta. So since this line is parallel to VP, so you are getting the true length. So you get capital A and capital B here. So that is what we will be able to find here. So this is the one which we have been talking about. Now we need to find out the true length in HP. Since we have to find the true length in HP, you have to take the line which is inclined to HP. The line which is inclined to HP is the front view, which is A dash B dash. With A dash as center, take the radius of A dash B dash and then draw an arc by using the compass such that A dash is above HP by 30 mm and B2 dash is also above HP by 30 mm. So that A dash B2 dash is the line which is parallel to HP that you can see here. With A as center, taking the radius of AB and draw an arc such that A is above HP and B2 is also above HP by 30 mm. So this line is parallel to HP. So when you are projecting this, so you are projecting this down onto the horizontal plane such that it will going to cut the locus of B in the top view. So this point will going to become B2. Then join A and B2 with a little bit thicker than the projector line. So the inclination made by this with respect to XY line or VP is phi. Then mark this point. Since this line is parallel to HP, so you are getting the true length here. You mark this as capital A and capital B. Then by using the scale, you measure the true length of this line or this line. Both will going to have the same distance. The true length will going to be 69.46 when you are doing it in computer. When you are doing it in manual, it will going to be 69 mm. And similarly, by using the protractor, you measure an angle of the true inclination with respect to HP, which will going to be theta, which will going to be 30.26 when you are doing it in computer. When you are doing it in manual, it will be 30 degrees. Similarly, the true inclination with respect to VP, which is phi. When you are doing it in manual, it will be 26 degrees, and when you are doing it in computer, it will be 25.59. And similarly, by using the scale, you find the length of the front view, which is A dash B dash, which will going to be 62.65 when you are doing it in computer. When you are doing it in manual, it will be 63 mm. So this is how we will be able to solve this particular problem in the sketchbook. Now we will going to apply the step by step, how we have done this in stepwise. So that has been shown here. So first we have taken NDA is in VP and 30 mm above HP. So you got this point, small a and small a dash. Then we have drawn 65 mm over HP. So you are going to get the locus of B in the front view. The top view of AB makes an having a 60 mm line which is inclined at 30 degrees to VP. So you are going to get the top view line. So once you get this top view line, so you are going to get this locus here. So this will going to be small b. So since we have the front view locus, so from here you draw a vertical projector so that it will going to cut the locus of B in the front view. So that you are going to get this B dash. Then join A dash B dash, you are going to get the length of the front view. You determine the length of the front view, which is the one. Then now we want to find out the true length in VP and also with the inclination made by this with respect to HP. So with A as center, take the radius of AB and rotate it and make it parallel to VP, because A is in VP, B1 is also on VP. Then measure this line is parallel to VP. So you are, and from B1 you draw a vertical projector so that it will going to cut the locus of B in the front view. So that point will going to become B1 dash. Since this line AB1 is parallel to VP, so you are getting the true length in VP. So denote this with capital B and capital A. Then join A dash B1 dash, which will going to be the true length with respect to VP and the inclination. So we measure the true length, which is 69.46 mm, and also theta, which can be find out. So this is what we have done. So with A as center, rotated, make this parallel to VP. So then it will going to be the true length in VP. So similarly, if you are in the second step, we are considering the true length in HP. So for that we have to consider the front view. So you take A dash B dash and rotate it and make it parallel. So that is what we have done here. Make it rotated parallel, that is parallel to HP. So that is A dash B2 dash. Then we are going to project it onto the locus of B. So when you are projected into the locus of B, you are going to get the true inclination and the true length with respect to VP. So that is what we have done here. So join between these two. So measure the angle of phi. So this is how we will be able to find the solution.